Right now, an artificial intelligence is rewriting software, testing its own work, and deploying it to production, all while human engineers are asleep. The economic pressure to automate this process is immense. In high-stakes environments, the entity that shrinks its decision-making cycle from days down to milliseconds gains a specific mathematical competitive edge. Directly integrating an autonomous agent into a production environment introduces an unpredictable blast radius. A single logic error or hallucinated variable pushed instantly to the main branch can trigger cascading failures across mission-critical infrastructure. This creates a conflict. Human review cycles are measured in hours, while the mutation loop operates in seconds. This speed gap makes manual oversight impossible, yet the randomness of standard large language models remains a liability. That gap is where ADAAD operates. It stands for Autonomous Device-Anchored Adaptive Development, and it approaches AI safety as a set of physical and legal engineering constraints. Rather than trying to eliminate AI error through larger models, ADAAD acts as the infrastructure surrounding the agent. It moves the burden of governance away from human eyes and into a set of hard-coded laws. This image shows the system's agent pack, the specialized AI workers named Architect, Dream, and Beast. Together, they are responsible for generating and optimizing the codebase. But these agents do not operate in a vacuum. Before a single byte of their proposed code can touch a live system, it must survive a mechanical gauntlet designed to prove it is legally and structurally safe. Consider a single modification to the system. The architect proposes a structural change, Dream identifies a more efficient logic path, and Beast optimizes the entire routine for performance. The moment that new code is compiled, it hits the constitutional gate. The gate does not evaluate the creativity of the solution, it only verifies strict compliance with the system's rules. This dashboard displays the 14-step loop every mutation must pass. It is checked against 23 rules, evaluating everything from resource bounds to test coverage. If it triggers a single blocking error, like an invalid syntax tree, it is instantly terminated and forced to iterate again. Clearing this gate proves the code follows the law, but a static test is not proof of real-world reliability. This diagram outlines the next phase. Once code clears the constitutional gate, it enters an isolated execution sandbox. Inside, ADAAD locks down network access and system calls to enforce a golden testable standard, removing the variance and randomness found in AI generation. This ensures every execution is deterministic. If the system is given the exact same configuration, it is mathematically required to produce the exact same execution result every single time. Because every execution is reproducible, the system functions as an auditable record. Human engineers can replay the AI's exact logic, inspecting every step for verification. This architecture takes the unpredictable nature of AI-generated software and converts it into a provable, mathematically sound process. When a mutation successfully proves its reliability inside the sandbox, it is officially merged into the live production codebase. At the moment of deployment, ADAAD generates a cryptographic hash that seals the entire lifecycle of the mutation, from the initial proposal to the final sandbox results. That hash is appended to a permanent, tamper-evident ledger. It secures a record of who made the change, why it was proposed, and exactly how it was tested. This addresses the core challenge of AI accountability. If a system failure occurs, the exact lineage of the AI's decision is permanently retrievable and legally auditable. This list confirms the scale of what this architecture achieved, a self-evolving codebase secured by a hash-chained evidence ledger, operating 193 unique governance events. The economics are visible in production. This entire factory, managing 440 commits, was built by a single founder. The evidence suggests that software value is being decoupled from human labor. We are moving toward a model where the speed of development is limited by the strictness of the rules, not the availability of human reviewers. This architecture points to a shift in engineering roles. In this framework, humans focus on defining the constitutional laws that govern the system, while the AI autonomously executes the work within those boundaries.